For lesson 7.3, we're working on evaluating and simplifying exponents just like we were in lesson 7.2, but this time we're focusing on a new rule. Anytime we're multiplying powers with the same base, we are going to add the exponents. And this is what I mean by that. 5 is the base number, 2 is the exponent. So here, 5 is also the base. They are the same base. Because they are the same base, we are going to add their exponent. Well, we don't have an exponent here, so we need to figure out what would that be. 2 plus what is equal to 11? In this case, it would be 9. So 9 would have to be the exponent. For this one, again, same bases. They're like bases. 5 to the 7th power times 5 to what power gives us 3. We know that 7 plus a number has to equal 3. We're going to add the exponents because our bases are the same. So in this case, 7 plus what is 3? That would have to be a negative 4. So we know negative 4 must be our exponent. Let's jump ahead to 43. A to what power times a to the 4th equals 1. A isn't there anymore. So for some reason, we didn't have to write a. The only way that a variable, would become 1 is if a was to the 0 power. Then it would become 1, because anything to the 0 power is 1. So right now we need to think, well, a to what power times a to the 4th power gives us 0. So we need a number plus 4 is equal to 0. So this exponent would have to be negative 4, because that's the only way our exponent is 0, and we need our exponent to be 0 because anything to the 0 power is 1. This works as well when we have multiple variables. Then we just have to match the x bases with the x bases and the y bases with the y bases. Well, in this case, we see that there's a y base to the left of our equal sign, and only one of them. And there is also one y base after it. So we know that this one must be squared, because y squared is equal to y squared, and there aren't any other y's on this left side. But we also notice that we're multiplying x bases, and there is no x base. So the only way for the x base to go away is if it were x to the 0 power, because anything to the 0 power is 1, and we can multiply anything by 1 without changing it. So to make this x to the 0 power, 3 plus what would give us that 0? So this would have to be negative 3, because 3 plus negative 3 is 0. We can use our new rule of multiplying powers with the same base to simplify this expression. We see here that this is multiplication. This dot also means multiplication, and we're multiplying the 9 and the z. So if it's all multiplying, it doesn't matter what order we multiply. So we can change it. It can be 4 times 9 times z to the 5th times z to the negative 12th. We still have all of the same values being multiplied together, but we can multiply the 4 and the 9 together, and when we do that, we get 36. And now when we multiply both z variables, they're the same base, so we need to add their exponents. So we have then z to the negative 7th power. At this point, we learned in lesson 7.1 that we can't have negative exponents. So we need to get rid of the negative exponent. In order to do that, we can put this over a 1 and move the negative part. So we're going to move the negative exponent to the bottom, which will leave us with 36 over z to the 7th power. And then this would be your final answer. We need to combine any like bases and then eliminate any negative exponents by moving them across our fraction bar line. If we look at number 14, it's a little bit more simplified. We have, again, like bases, m to the 3rd and m to the 7th for a total of, m to the 3rd and m to the 4th for a total of m to the 7th. For number 15, we have a 5c to the 4th times a 1, even though there's not a 1. In front of the c, we still have just the 1c to the 6th power, 1 times the 5 leaves us with just 5. And then we have like bases. C to the 4th and c to the 6th, we're going to add their exponents, so then we have c to the 10th power. We don't have any negative exponents, so this would be our final answer. If we look at number 17, again, the 7 and the 8, the whole problem is just multiplying. This is multiplying, in between parentheses is multiplying, and this is also multiplying. So we can say 7 times 8 is 56, and then we have like bases. Even though right now it doesn't look like there's an exponent with that second x, it always has an exponent of 1. So we have the 5 plus 1 giving us x to the 6th power. If we look at this one, again, there's a 1 in front of x. 3 times 1 is 3. X squared and times x squared, they're all the same base, so we need to add their exponents, so we have x to the 4th power. For this last one, it doesn't matter that there's a negative 1 there. We still want to simplify it first before moving anything, because sometimes when we simplify, it actually makes it so we don't have to move it across the fraction bar line to eliminate. All of our variables are b variables, so they're like bases, so we are going to add the exponents. So we're adding negative 2 plus 4, and even though there isn't a number here, there's still 1. There's still 1b present, so we have to add that as well. Negative 2 plus 4 gives us 2. 2 plus 1 gives us 3. So now we know that we have b to the positive 3rd, because negative 2 plus 4 gave us positive 2, and then positive 2 plus 1 gave us 3. So b to the 3rd is our answer. It wasn't negative, so we don't have to take another step. That's just our final answer. Here are some more examples that I'd like you to try. You can pause the video and calculate them before checking to see if you did them correctly. Again, it's all multiplication. For number 21, again, it's all multiplying, so it's negative 2 times 3.5. Well, 2 times 3.5 is 7, so now because of this negative, it's going to be a negative 7. This exponent only goes with the m. Same thing with this exponent, it only goes with the m. So now that they have like bases, we are going to add exponents. And that leaves us with m to the 0 power. We also know from our previous lesson that anything to the 0 power is 1. So if we're multiplying negative 7 times 1, that's just going to leave us with negative 7 for our final answer. Looking at number 23, we have x variables and we have y variables. So we can combine the x with the x. 5 plus the negative 6 gives us an x to the negative 1st power. And then y squared plus y to the 1st is going to give us y to the 3rd. We're still not finished yet because we have a negative exponent, so we can put this over 1. Because to get rid of a negative exponent, we have to move it over the fraction bar line, and we only move what's negative. So that leaves us with y to the 3rd over x for our final answer. For this next one, we have 3 numbers that are all being multiplied together, so we can say that we have 5 times 3 times 3, and then organize our variables. So then we have an x to the 5th power. We also have an x squared, and now we also have a y to the 6th. So now that they're all organized, we can multiply them together and simplify based on their like bases. 5 times 3 is 15. 15 times 3 gives us 45. X to the 5th and x squared, we add their exponents, so we have x to the 7th, and then y to the 6th. We want to double check if there's anything else. No negatives, no 0 exponents, so this would be our answer. We look at this one, we have x squared and x to the 4th. When we combine them, it's going to be x to the 10th. And then there's nothing to combine with the y squared, so that just stays as y squared. Remember, we always want them to be in alphabetical order, so it's going to be the x first, then the y. Our last example like this. In this problem, we have a to the 6th and a squared. It's all being multiplied, whether there's a sign in between or not. These two are being multiplied, these are being multiplied, and so are these. So we can say that we have a to the 6th times a squared. Those are both of our a bases, times b to the 3rd times b to the negative 2nd power. Those are our b bases. We have 1, 2, 3, 4 bases in our problem. So then when we simplify, we get a to the 8th times b, 3 plus a negative 2, just gives us 1. We don't have to show that 1, so really our answer would be a to the 8th, b. And we don't have to have that multiplication sign in between because it's still multiplying without it. One final problem before we go on to our homework. In this problem, it's similar to ones you've seen before. This is multiplying. In between our parentheses, we're multiplying, and we're multiplying here. But it just looks like it's in scientific notation, and that's exactly what it is. So because it's all multiplying, we can change the order and say that we have 3 times 6. Those are like bases because right now they're just plain numbers. We can multiply them. And then we have 10 squared times 10 to the 3rd. They both have exponents, and they're like bases, so we can combine them. 3 times 6, we can just multiply together, giving us 18. So we have 18 then times, and I'm going to write it back into scientific notation, because typically when it is given to you in scientific notation, the final answer should be in scientific notation. Then we can simplify this. They're like bases, so we add their exponents. And then we have times 10 to the 5th. At this point, it's not in scientific notation. So we have to write it into scientific notation by rewriting this 18 into scientific notation. And that would be rewritten as 1 8/10. For this to have the same value as 18, we would have to multiply it by 10. So 1 8/10 times 10 is 18. They should have the same value at this point, and because they do, then we can write the rest of it. So you would say times 10 to the 5th. Then again, we can combine any like bases. So then we would have 1 8/10 times 10 to the 6th power. And that would be our final answer. Once you finish the video, then you can begin the homework. This is still day 1, so a reminder that we would complete this lesson tomorrow.